What does that tell us about the story of where open source security is headed in the AI era?
But I think in that AI era, it kind of flips because most of the eyes now are just from attackers running campaigns. And so it's more of a risk at this point.
What would you generally need to see to trust a tool like this in production, and what makes you nervous about maybe handing it the keys?
My answer might have been different. I think now CISOs and security leaders are having to take risks that they would not have otherwise taken, that they don't necessarily want to take.
How does that work in practice within an organization, within teams? And how do you kind of keep it from becoming like one giant risky refactor that developers are pushing back on, basically?
I don't think that works because MTTR is a very forgetful metric, because you can have a variant of an issue that you fixed last week come back as a brand new finding in another service with a fresh MTTR clock this week, and you'll go and refix this as quick as possible just to make the number look better.
Thank you for joining the Resilient Cyber Show. My name is Chris Hughes. Today I'm joined by JJ from Gecko Security along with Ryan Knisley. Gentlemen, thanks for being here. Looking forward to chatting today, but for folks that aren't familiar with you guys, the team at Gecko Security and your background, can you tell us a bit about the team, starting off from there, maybe JJ on your end?
Yeah, definitely. I can give you a bit of background. So I'm JJ, one of the co-founders, the CEO of Gecko. My background is all in cyber. So I joined the UK intelligence service when I was 17, doing kind of security research, vulnerability research, exploit development, mainly around like critical infrastructure, which kind of funnily enough is now what all these AI models are starting to do for us, but kind of without the humans. And then after that, I spent a few years in red teams, mainly in the financial sector. And what we're doing at Gecko is building an AI security engineer that reasons across code, infrastructure, and documentation to find and fix entire classes of vulnerabilities at scale. And so kind of the way to think about us is we sit a little bit higher up in the stack than most code scanning tools. But when we scan code, we have context from things outside of the application layer. So when we have a finding, it's already mapped to what exploitability looks like in production, because we know if it's reachable, and to the real business impact, because we know what data it touches. And the thing that we're seeing become kind of more important now post Mythos is fixing at scale. And because of the way we do program analysis and model vulnerabilities, rather than going through and fixing issues one by one, we can trace groups of them back to the design decision that created them and then eliminate entire classes at scale. So you never really see the same vulnerability twice.
That's awesome. Yeah, as you said, your background, I couldn't help but think of Jack Cable, if you're familiar with him in the United States. Similar background in terms of going in the government incredibly young, kind of then moving from the commercial sector and diving into AppSec deeply. If you don't know each other, you guys would get along super well. How about you, Ryan? How about your background?
Yeah, hey Chris, thanks. Ryan Knisley. I joined the government not quite as young. I was 19 when I joined the Army, dropped out of college, ran off to the Army, and then joined the Secret Service after that. And where I got into cyber, back then it was really just forensics. It was like digital forensics. And I kid you not, Chris, I get to the office and they're like, hey, you're pretty good at email. You should probably be a cyber agent. And so we're going to send you off to the government cyber school and learn all things cyber, which was great. What a blessing. Most recently, I was the CISO at Disney. I was the CISO at Costco before that. JJ and I met through a mutual friend who was one of Gecko's seed investors, and he connected us, and we've gotten to know each other the last several months. So glad to be here and looking forward to this conversation.
That's awesome. Yeah, your background sounds similar to mine with the military, and as they say, no good deed goes unpunished. If you know a little bit about something, all of a sudden you're a SME and you get given more responsibilities, which is the way of the military in my experience. So JJ, you gave a little bit of background on Gecko, but I know you're only about a year old here, and as you describe it, it's not just another scanner, but an AI security engineer that reasons across code, infrastructure, design documents. What gap in AppSec made you want to build something that sits above traditional SAST rather than alongside it, especially like right now with the kind of rise of LLMs and agentic AI and so on?
Yeah, I think if you kind of look at SAST and AppSec, like a few years ago, pre-AI, it was kind of a category that most teams felt that they were wasting like money or effort on. Like I don't really know anyone that ever liked any AppSec tool. And I know people had preferences, but I think most tools kind of fell short. And the reason kind of came between the trade-off of noise and value. Like most teams never really put in the time and effort needed to tune scanners. And so you got flooded with a bunch of false positives, or you just kind of left the alerts to pile up and never got through them. And I think a lot of AppSec teams we spoke to were more excited about something like Wiz than any other AppSec tool. And part of that one was because they had really good UX, but I think the real reason is because they built enough out-of-the-box context that really pointed you straight to exactly what mattered. Like, they wouldn't tell you you have a vulnerability. They would say you have a vulnerability in your cloud infra with overly permissive access that's exposed to the internet, and then gave you the full attack path for that. And that was kind of the big unlock for most practitioners. And then so we kind of took that Wiz idea, extrapolated it onto AppSec. And when you start to realize most of the important information that tells you if something's exploitable, like the product logic, like the business context and the architecture, all of that lives outside of the actual code that you're spending most of your time scanning on. And so that's kind of why we built Gecko, to scan with this larger view of the application from the start. And kind of when you have all of that context on how the app is supposed to work across the full stack, you can start doing things that SAST would never really be able to do, like catching business logic issues as code is being written. So that's kind of the train of thought of how we saw AppSec before AI and kind of how it's transitioning now.
Yeah, you made a comment that made me want to ask a question. You mentioned about, you kind of used parallels to Wiz and like their good UI and UX. Like, there's been this trend of the conversations around agentic AI, like agents, and going headless. I'm just curious, like, I've seen some security vendors going in that direction. Like, what do you think of that trend?
I think that's there's so many angles I can take that on. I just don't think we've seen many people do it correctly well yet. I think it's not super clear how teams are going to use the agent, whether it's going to be lots of different vendors that have their own like agentic platforms and you have to interact with that, or there's like a one Claude agent that sits in your kind of terminal, whatever, that interacts headlessly with all these other applications. I think time will tell, and kind of whatever UX developers prefer will be kind of the one that everyone transitions into.
Yeah, agreed. I'm just curious to see how it plays out. It's an interesting trend. So a core idea of the work that you all do in there, JJ, is like scanning with context from outside the application layer, the business logic, the architecture, runtime, to understand whether something is actually exploitable. Why has business logic been such a hard thing for traditional stack analysis tools to reason about? And, what does the outside context actually change about the findings? Because you talked about, tons of findings that had lack of context, kind of just dumping these long lists on developers, causing friction and so on. Like, what changes with that approach?
Yeah, business logic has been, like, those types of issues have been very hard to find for a long time. And I think in the OWASP top 10, they've been at number 1 for like the last 5 years. And it's also kind of been a promise from like every vendor that they can kind of find these issues in enterprise code. I think a lot of people are familiar nowadays with the architectural reasons why SAST could never find them, like legacy SAST. Like, these types of issues often require very long sequences of dependent operations, and they don't really fit a clean rule that pattern matching scanning would usually go and find. So you get left with a bunch of false positives because these types of issues are so specific to your code base. I also think there's a newer misconception, which is that if you can just take an LLM and point it, maybe with a harness, at your enterprise code, you'll be able to find all these business logic issues. And I think teams that have tried this know it's not that simple and it's not true. And also, even as the models get better, this is not going to start to work. Because if you kind of take a step back and think about what actually are business logic issues and how have we always found them, it's really just humans doing either design reviews, threat models, and then testing against a live application. Essentially looking for like a mismatch between what is the developer's intended description of this feature and how is the code actually looking in the application. And that's really why pen tests and bug bounties have been like an important part of any security programs. And so most people think LLMs will be really good at kind of following this human reasoning, so they assume that you could just point an LLM at the code and find these business logic issues. But I think if you take like an example, like let's say you had a microservice with an endpoint that returns a user's files by user ID and it had no auth check. Any LLM going to look at that code in isolation is going to think it's a textbook IDOR. And that's right if this is like a document storage application where files are supposed to be private. That is a critical vulnerability. But if this is like a social media application where everyone's supposed to see each other's posts, that is expected behavior and that's not a vulnerability. And that source of truth that tells those two things apart, that doesn't live in the code. That lives in your design documents, your architecture, your runtime. And that's kind of the core idea here. Most people think this is solved because they see LLMs finding business logic issues in open source code, but all of these models are essentially trained on that and know it like a 20-year-old engineer that's sat on this project forever. So it's really just in an enterprise environment, you don't get that same knowledge for free. You have to take all of this other context externally to actually build what is the expected behavior, and then go do your vulnerability analysis on that. So that's kind of why it's so important to find business logic issues. You need all of this context.
Yeah, I think what's interesting here is like I watch this space super closely in AppSec and vuln management and so on, and like there's a lot of players, either shifting incredibly far left to the design space, as you said, like
Yeah.
kind of product security angles type things, or runtime context. But you're talking about kind of bringing all that together and turn it into a comprehensive approach, which I think is a bit differentiated from a lot of the players I kind of watch in this space. And I want to ask you, Ryan, like knowing that you've been an enterprise CISO and security leader, like there's the age-old line like, attackers thinking graphs, defenders thinking lists. And I know JJ and team have been showing like account takeovers by chaining separate issues together and so on. How does chaining change which vulnerabilities a team prioritizes versus just working down like a flat list of findings, for example?
Yeah, man, age-old problem, Chris. You know this. Like we would talk about, no one's ever going to go after lows, right? At enterprise, when you've got hundreds of thousands in your burn down, hopefully that's all you have is hundreds of thousands, if not millions, in your burn down. You're never going to attack mediums and lows. It just isn't going to happen. But we've always said, the industry's always said, which one of these lows can get us? And we never had context to that. And even going back to the business context piece, in reality, bringing in business context at an enterprise company, at a really large enterprise company, assumes that you know where all of the business context lives and you can connect into it, and you know which is the system of record or the system of truth, and you've got multiple versions of the same, sort of context out there. Which one do you action off of? It's incredibly complex. I think with chaining these vulnerabilities together, this new capability now allows us to focus on what's most important. I don't care if it's critical, if I've got a compensating control around it. I care if it's low and chained together with another low and a medium, I can be massively exposed. Like that's real value to me. That really changes the dynamic in application security and how AppSec teams operate and focus.
Yeah, I think there's other kind of parallel things that are driving that too. And JJ, I want to touch on this with you, like from the product side. Like I came out of the federal space. Like I know Ryan talked about his military background. You did public sector time as well. When you first got started, like here in the US, there's a binding operational directive right from CISA around prioritizing based on risk, not just base severity scores of CVSS, which that was broken for a long time. I'm glad we're changing it, but it took a hell of a long time to get there. Like from your guys' side on the product side, how are you guys really coming at this? And then also, I kind of watched the, I guess you say AI capability curve in cyber, and like there, a lot of labs and other research institutes are showing that these models that they're using for vuln identification are starting to chain together vulnerabilities too. So it's obviously a capability that the attackers are going to be looking to use too.
Yeah, I totally agree. I think kind of where we are today, the future of cyber is no longer about isolated issues anymore. Like on the attacker side, exploit development is basically getting commoditized. We're heading toward a world where like the entire internet might just turn into one big bug bounty scope with agents just running all of these campaign level attacks on everything. But on the defender side, we're still using this old lens and the old way of like ranking risk and severity, like you said. And teams are kind of just drowning in all of this noise because findings problems got very cheap, but this holistic view of like what's actually exploitable across all of this kind of still isn't there. And that graph idea is essentially just kind of a way to describe that shift, like attackers thinking graphs and defenders thinking lists. And kind of the way we designed Gecko is like onboarding an engineer who's read every design doc, every line of code, the infrastructure it runs on, has followed you through the Slack threads where all of these decisions are getting made, and then remembers the last incident and the risk that you chose to accept. And kind of once you have all of that context, most of these triage decisions get quite easy and kind of the ranking flips, because the one critical on paper that is usually probably harmless in your environment, you'll start to realize that the 10 lows chained together is the one that actually hurts the asset that you care about. So instead of like burning down this flat list of misaligned severities, like you said, you're working off a graph that connects everything together. And kind of when you come to this on the fixing side, because you can have all this data, but if you want to go and fix all those 10 lows, we can see which low is going to break that entire chain, and we'll know that fixing that would have required 3 different dev teams to go and approve this, and it would have taken weeks to write a code change that you don't really probably want to do. So you can just spin up an AWS Lambda as like a mitigation today with one line of code that's going to kill this like attack path. And really like the core thesis of the way we designed Gecko is just to flip teams from thinking about this as the way they're doing now, but kind of the decades old SecOps methodology, just all of that, but applied to vulnerabilities. So that's kind of how we see it.
Yeah, you opened this up. Oh, go ahead, Ryan. Go ahead.
Chris, I was going to say, you mentioned something about teams shifting even further left, right? We've been talking about shift left for, I don't know, 15 years, over a decade for sure. And we're still not there. And, if I'm a practitioner today, my dream state is where we really truly shift left and we prevent things from getting into production, right? We want to do all the hard work up front, make that burn down list go from hundreds of thousands to dozens maybe, and then really attack those quickly. I think that's what we have to get to because, JJ, I think we'll talk about it a little bit. This MTTR stuff just isn't going to work. It's a dated model. We can't keep doing it. It's a fake metric that makes teams look good when it shouldn't reward teams for continuous bad work. And so until we really can push left truly and prevent things from getting into production, we're going to be playing the same game. Jen Easterly, when she was at CISO, she's been beating this drum for a while. We've got to expect more from software vendors that they produce really high quality secure code, and we've got to expect the same from our own teams internally at these large enterprises. Like we've got to be producing secure code that we're deploying into our environment. Yeah,
she often quips, we don't have a cybersecurity problem, we have a software quality problem, is the way she frames it. And so, JJ, you actually teed this up perfect, because I was going to ask, you opened this talking about eliminating entire classes of vulnerabilities, which was another kind of theme of CISA underneath Jen Easterly's tenure with folks like Jack and Bob Cable and other people who were kind of championing this. But that conversation, it often was framed around switching like memory safe programming languages and things like that. Instead of fixing one bug at a time, like you're talking about tracing groups of vulnerabilities back to the design decisions that created them and eliminating entire classes of vulnerabilities. Like how does that work in practice within an organization, within teams? And how do you kind of keep it from becoming like one giant risky refactor that developers are, pushing back on basically?
Yeah, I think the instinct for most teams right now, like especially given Mythos is kind of here now, is the answer is like, let's just patch this and remediate this quicker. And then how do we measure that? We'll use MTTR and call that like a healthy security program. But like Ryan said, I don't think that worked because MTTR is a very forgetful metric, because you can have a variant of an issue that you fixed last week come back as a brand new finding in another service with a fresh MTTR clock this week, and you'll go and refix this as quick as possible just to make the number look better. But you're kind of stuck on this treadmill and you're not actually meaningfully reducing risk. You're just forcing teams to go and close a bunch of tickets. And so kind of the metric that we built Gecko around is this like idea of a recurrence rate. So what percentage of these findings are a variant of a class that you've already fixed? And that way you can kind of start to make more meaningful security improvements, because you're going to stop treating a ticket as like the unit of work, but make the class a unit of work. And like what that looks like in Gecko, like you said, is rather than going through and fixing one by one, we trace groups of vulnerabilities back to the design decision that created them. Go and find every last variant of that root cause across the entire organization. So from design to CI/CD and production, and then eliminate all those classes so that you'll never see the same one twice. And then I was just going to say, to answer like the second part of that around like the risky refactors, we kind of think about this like a feedback loop that gets more aligned to the code base over time. So one feature we have is the developers can talk to the Gecko bot in natural language, and everything that they say there is stored to memory. So it keeps learning your environment and your intent over time. And every fix that we will generate will run against the existing tests. We'll also build new test cases to like widen the coverage as you go, and then turn those vulnerability lessons into guardrails that then enforced in like the design stage and inside the agent that's like writing your code. And I think like once you start to make all of those shifts, you start getting a lot of like valuable insights. And I'm actually doing a talk at Black Hat next month about this, where we took a bunch of publicly available vulnerabilities across some of the biggest like open source companies, did this experiment where we traced all of their bug bounty reports back to the design decision, and then showed how if they had stopped just repeating these bug bounty payouts and refixing the exact same variants, you would have saved all of this time and all of this money that came in later as fresh bounties. So
yeah, that's funny about kind of just rehashing the same types of findings, right? And just paying them out repeatedly. There's an economic angle there for sure beyond AppSec. So I want to ask you a question about this from the leadership side, but starting from kind of the the Gecko side, right? Like, JJ, you brought up this, and I saw it on the website too. There's a case study for Cal.com, where they have replaced 4 tools with Gecko. And I touched on this when I talked about runtime and design stage, et cetera. And, the Cal.com also, I think, went from being open source to closed source, partly because of AI-driven threats, and, being open, can be too dangerous, right? Like there's a age-old saying of under enough eyeballs, all bugs are shallow, but we historically haven't had enough eyeballs. And that's kind of changed now with agents and autonomous, identification, exploitation, et cetera, things like that. What does that tell us about the story of where open source security is headed in the AI era?
Yeah, so also just to like extra background on Cal.com, they were like one of the largest open source scheduling platforms. They still have like 1 million users, and they would use like a bunch of big companies like Coinbase, Vercel, Ramp. They were open source for 5 years, and kind of like you said, what really tipped them was the like economics of this was completely changing. Like they started to adopt AI coding tools. Their PR volume went from like 30 a day to around 100, and they only had 20 engineers and a 1-person security team. So their attack surface was just like exploding at a very quick rate, and AI made finding, exploiting vulnerabilities in like public open source code very cheap. So like you said, kind of being open source stopped from having this community advantage, what it used to be, and started becoming almost like a liability, because every time you are like making a pull request, changing a single line, attackers were just reading every line of that. And so in April, they went closed source to kind of protect customer and data. I think that probably is a signal for where like open source is heading. Like you said, a long time being open basically meant more eyes on the code and more people catching bugs. But I think in that AI era, it kind of flips, because most of the eyes now are just from attackers running campaigns. And so it's more of a risk at this point. And so their old security stack was like 4 different SAST tools. They were running like legacy SAST, some AI native SAST, and AI pen testing tools. And then they ended up replacing all of this with just Gecko, because everything was so spread out. They didn't have like a single reliable source of truth to get everything fixed quickly in time for all of the attacks that they were facing.
Yeah, I want to ask you, Ryan, in the context of ripping tools out. I hope you're probably about to go there, but like historically, like it can be painful, right? Like there's a reluctance to change, whether it's contracts, whether it's costs, whether it's familiarity from the workforce with a particular tool, a set of tools, and so on. Like what really moves the needle of having a security leader being willing to like make a change to their AppSec tools?
I love hearing that case study, 4 tools replaced with Gecko, because it's near and dear to my heart. I mean, it was something I think, as a CISO, I took on pretty early before it was kind of in vogue to do so, and we have a shiny object problem in security still, where we just continue to stack tools. And I always thought, and I've told this story, Chris, quite a few times, but I had my team came to me and said, hey, I'll protect names. So-and-so wants to take vacation. And I said, well, why is that a problem? And they said, well, because they're the only admin on one of our 5, endpoint tools that we have. And I said, okay, well, like anyone else hear this problem that we have? This is insane. And so that's what really started me on. We've got to make really hard decisions and get really methodical about our stack. And, I worked for some great CFOs that thought this is a risk reduction. This isn't a cost savings exercise. This is a risk reduction exercise, because if I can take 10 people on my AppSec team and take their tooling from 5, 6, 8 to 2, I can now cross-train. I can train them more deeply, right? It's great for them. They love it. The problem is a lot of people love their tools. Change is hard, and they don't want to give up what they know. But at the end of the day, it makes the organization better. It reduces complexity. It reduces risk. It's a talent development issue, because I can then cross-train even outside of AppSec. Let's say I can cross-train somebody in a completely different area because we have capacity to do so from a human capital perspective. I agree. We've never had enough eyeballs. We've always had way more tools though than we need.
Yeah, I think that's speaking to a broader trend that's happening right now in terms of consolidation. And you raised some excellent points. It's like, yes, there's the economic aspect, but there's a cognitive overload on teams. There's a continuity when someone's out or someone moves on, right? And they're the only person that knew XYZ tool. Like there's a lot of benefits of having a consolidated approach in AppSec and cyber more broadly. Like there's that trend in AppSec where there's a kind of a platform push, right? And teams are being tired of stitching together scanners, from different disparate vendors and tools and so on. Maybe starting with you, Ryan, looking out a couple of years, like where do you think that this kind of AI-driven AppSec trend lands, and what could consolidate away versus what still needs like a human security engineer in the loop, for example?
Yeah, boy, if I could predict the future, Chris, man, I'd start a company around it. I think we're going to see real compression across a lot of different areas that had historically been a bit disparate and ran kind of autonomously and independently of one another. And so whether it's, application security and pen testing and SAST and DAST and everything, all that, even DLP a little bit to some degree kind of coming together in some big platform of whatever that will look like, I think we're going to see real compression across a bunch of areas. As far as like AI adoption and willingness to kind of have this autonomous engineer, I think 6 months ago, my answer would have been very different. Maybe 3 months ago, maybe 4, let's call it February. My answer might have been different. I think now CISOs and security leaders are having to take risks that they would not have otherwise taken, that they don't necessarily want to take. But out of necessity, we're having to turn more over to AI, to that security engineer than we would have otherwise. And it's really about trust. Like we've got to have trust, but we're gonna accelerate that trust building really, really quickly, because otherwise teams that are slow to adopt, we're gonna get dusted. We're gonna get left behind. We're gonna get absolutely owned, and it's not gonna be great. And so it's an uncomfortable position for a lot of security leaders, but it's the one that we're faced with, and it's the reality of what the attackers are doing to our industry.
Yeah, JJ, just to build on that, not only where do you anticipate it's going, but where are you kind of trying to drive the industry, right? From the product side, from the vendor side.
Yeah, I totally agree. I think kind of what gets consolidated away is kind of the old way of doing the finding layer, like the pure just SAST, DAST, SCA scanners that all just go and produce their own list, that also have these misaligned severities and then also a bunch of false positives. I think that whole tier just gets collapsed into like one content layer, because I think that, like I said at the start, the value was never in like the individual signal. It's correlating all of them, understanding, is this reachable? Is it even deployed in our like organization? Does it touch any sensitive data? Is it actually exploitable? And once you're reasoning across like all of that, running 4 separate tools that can't really see any of this kind of stops making any sense. I think the part that doesn't get consolidated away is kind of the human lens of this, and the human in the loop is probably going to move up a little bit more, because when a finding is basically free because it's so cheap to find vulnerabilities now, a lot of the fixing is going to start to get automated, and then the scarce thing left is the judgment, deciding like what is correct, what is it supposed to look like in your own system, are we going to even accept this risk on purpose, and kind of owning that design decision for the whole class of bugs in the organization. I think that's the part where, like in 2 years out, this is kind of my bet of where everything's going to kind of go to.
I just to add to that, I think human in the loop for sure, and kind of this human QA aspect, I think will be around for a while, but I think we'll start to see, like with any adoption of technology, we're going to start to turn things over more and more and more, and we'll allow humans to then work on the highest value activities for their organization, which is great. The problem is like no security team wants to bring down the business, and having done that before, just, being transparent, it's an awful place to be. And so it's not what we want to do as security leaders, but it's the reality of what happens and what probably will happen into the future with just more AI coming to our environment. I think CISOs and security leaders are being positively pressured, I don't want to say negatively pressured, but positively pressured to push the adoption of AI faster, push the adoption of technology, and this happens to be AI technology, faster than they've ever been expected to adopt technology, in the past.
Yeah, there's definitely a massive amount of pressure, whether it's from the board or executive leadership or the peers in the market and so on. And you talked about AI, Ryan, maybe last question for you is, you've been a CISO at a large enterprise environment, you've worked strategic roles on the product side. When security leaders hear this phrase of, AI security engineer or autonomous security engineer, the first reaction is often skepticism, right? What would you generally need to see to trust a tool like this in production, and what makes you nervous about maybe handing it the keys?
Yeah, taking down a data center, that's what makes me nervous, having done that before. But it's those types of business impacting events that security can cause, and, let's say an AI engineer can cause, is concerning. The reality is, Chris, is, my approach as a CISO was always talk about the risk, share the risk with the company, and in this case, the narrative for me would be, I would express to senior leadership, we have to do this. This isn't a nice to have. This is a must have, and we must do this. In doing so, there are risks associated. We're going to be thoughtful. We're going to try and mitigate as many risks as we can. But we need to sort of adopt this AI early and widely across our organization. That said, again, like any technology adoption, there's going to be this sort of trust curve that we're going to build over time. I think that trust curve goes from 2 years to like 6, 8, maybe 9 months. It's much faster than it would be otherwise. But again, turnover low level activities, sort of fully autonomously, as JJ said. Like, let's give them to eat the low hanging fruit, and then as we build capability and comfort, we can start to turn over more.
Makes sense. So JJ, last question for you before we wrap up here. Like, from your side, from Gecko Security, where can folks go to learn more? You talked about Black Hat. Maybe tell us a bit about that upcoming talk and so on.
Yeah, so we're at gecko.security. That's where you can find more. We also have a free version, so people can run it on their own code base, try it out, and then see what the platform looks like. If anyone else is interested, you can talk to one of the founders. Me and my co-founder, we have like a demo call that you can book. The talk at Black Hat is largely what we said before. It's going to be the larger point around like why MTTR and the old way of measuring and evaluating AppSec is kind of outdated in this post-Mythos world, but then also backed with like real technical vulnerability examples from a bunch of the biggest open source companies, and then kind of leave teams with a way to think about how they can restructure their AppSec program to stop like chasing vulnerabilities, but start to actually move the needle on like eliminating classes at scale, and then stop paying a bunch of bug bounty payouts or saving a load of time.
That's awesome. Yeah, I'm excited about where this is going, obviously from the technological side, but the consolidation, the kind of ability to get to things. We've talked about security by design and shift left and all these things, but they've been elusive and problematic for so long. And it seems like we have an opportunity to finally kind of make good on some of those ambitions of ours within AppSec and cyber. So I'm excited about where it's all headed. JJ, Ryan, thanks so much for jumping on, and I'll talk to you all soon.
Yeah,
thank
you, Chris.
Take care.